Well, we are looking across the Hudson Bay at New York City. The lights are very bright. No fog. It's fairly a clear day, a little cloudy. But you can, the view is very clear across New York City. Straight ahead is downtown Manhattan. There's the traffic moving very smoothly. It's April the 23rd, 50 degrees. I'm panning over, I believe, oh yeah. I'm moving to my left to show you New Jersey. There's a light in the sky, blinking. I don't know if you can see it. So, yeah. It's two lights, but the light that's going to come to me is going to move to my left. You're right, because I've been scanning the skies for a while now, so I know exactly how they move. Most of them, actually. Light straight ahead is going to come towards me, and then move to my left. You're right. So there are two lights now appearing. More than likely they're helicopters, so I can see three lights now. Two straight ahead and one to my left. There's the one to the left. So you can clearly see the three lights. But I believe they're helicopters. They move very slowly. So nothing really unusual about that. Unless they just appear in front of me, then I know I have a problem. See, they can move to my left. Yeah, right. And that looks like around, say, coming from Harlem towards Midtown Manhattan, and then moving towards New Jersey. So the skies are fairly clear, a little cloudy. Let's look at the traffic again. Yep, the traffic is moving fine. Go up to the lights. I believe, I thought that light was a beacon, but I believe it just disappeared. There's no lights directly above Midtown Manhattan as yet. So these lights are moving very slowly. Barely moving. There it is. It's way out there. Well, when you join me at my whiteboard, I've been talking about some new physics. I've been discussing dark matter, dark energy, the pulse, the big pulse, the cosmic cake, where the strong nuclear force was created, why there are quarks and different flavor with different colors of the quark. Right, the colors mean charge. I'm going to discuss that at the whiteboard. The main thing is exactly where these quarks were created at the beginning of the universe. So I'm going to discuss that after I finish filming. There are like 4 lights. 1, 2, 3, 4, 5, 6. I count 6 straight ahead. It was a busy night. And they're going to move to my left, your right. Well, most of them, a couple of them. At the whiteboard, we're going to talk about the theory of everything. The basic idea behind that is we have to take Einstein gravity of the big. You know, the moon, it goes around the earth. Right, that's the gravity of the large, with the gravity of the small, which is going to be quantum part, you know, quantum energies, and you know, electrons, quarks, and stuff like that. You put both of them in the equation, and you come up with a theory of everything. Like I said, there are 4 forces, at least 4 forces without gravity, and gravity is missing in the standard model. So we have 4 forces so far, plus gravity. And I'm going to explain that again because that's very important. So actually what we need is a Lagrangian, which is going to be the equation for the standard model for all the particles and forces in the standard model, combined with the gravity and the energies of the large, like the sun, the galaxy, neutron stars, and you combine it into one equation. And that equation, I believe, should come up to 0, because the total energy in this universe is 0. And that's going to be the Lagrangian. So that's going to be the Lagrangian total energy. That's what the formula is going to be about. So I will discuss that. But not too much in depth as usual, because I want to finish off with the strong forces. I want to talk about how we got charges, why charges are positive, why charges are negative, why why the electron have a charge, stuff like that. And if you recall, I had said that if you during a big pulse, if you go in one direction, if it pulses outwards, for example, you're going to have the characteristics of an energy zone, and as it pulls back inwards, you're going to have a different characteristics of that energy zone. So you can have an electron, or the charge is going in one direction, which would be negative, and then when it pulls back outwards, that would be positive. Stuff like that, but we will get into depth. So there's a lot of lights out here. And then since it's a spring right now, the plants are blossoming, flowering. So, very, very bright colors in the flowers. So I took a few pictures. So I will insert that in the video to give you an idea of what the trees look like during the spring. Let me see, there's 1, 2, 3. 3 lights. 3 lights in the general direction, straight ahead. Nothing unusual. One of the front one, the one in front, is very, very bright, as you can see. Right. It's very close, coming close. But it's gonna move to my left. Should. You're all right. So this one is coming farther than the rest. Let me see. Where is it? There it is. It's actually moving to my right very slowly. Almost hovering. Then it's going backwards, so I guess it just circled. It comes towards me, it moves to my right, and it circled backwards. Nothing unusual with that. Motorcycles. So it is partly cloudy, so more than likely there are clouds over downtown Manhattan. This is why I'm not seeing any lights out there. So there's none over Manhattan, downtown Manhattan. It's straight ahead. Clouds are probably clearer out there, so this is why I can see the lights. I mean, this is the biggest city, so if there's going to be any UFOs, it's going to be over this big city. I mean, it could be over any city, but they will visit this big city also. That disappeared very quickly. Well, we are scanning the skies for UFOs. So obviously those lights are going to be helicopters because they're flying very low to the skyline. And I have not seen any erratic movements. Okay, so join me at my whiteboard. Thanks. Here's another very colorful tree. Well, here's another tree. A lot of reds, pinks. Right. I don't know what kind of tree it is, of course. I'm pan over here for a minute. Another one over there. Bright colors. And over here, more bright colors. Okay. These trees here are lighter in color. So you can see, instead of they are colorful, but they're lighter in color. Looks like they have a fruit growing from it. So let's see these other ones. So whoever knows the names of these trees, you can comment below. New York City, Flora. I'm right under one of these trees here, as you can see. I'm right under it. See, let's go down a little. So, right on it. It's flowering, blossoming. So, right under it.